That's the clock just turned to midday, and with that, I would like to say good afternoon, everyone, and a very warm welcome to you all to the first over 3 online lunchtime seminars to outline the science behind ammonia, which will help inform future policy. Many thanks for joining us. My name is Alistair Carson. I'm really pleased to be chairing the series of 3 seminars in my role as DARA Director of Science, Evidence and Innovation Policy Division. Paddy, if you just flick to the next slide, please. Ammonia is not a unique challenge to Northern Ireland. Countries across the world are working to find solutions to what is a complex issue with no quick fix. However, there's a lot we can do together in Northern Ireland to reduce our emissions, whilst at the same time help our agricultural sector to become more efficient and sustainable in the longer term. We in DARA are committed to working with stakeholders to develop solutions which are ambitious, which are proportionate, and which are practical, and which will underpin green growth. Delivering on this challenge requires a high-quality evidence base, and it is this science which will be the focus of the webinars this week and will inform the proposals within DARA's draft ammonia strategy. It's intention that this draft strategy will be consulted upon later this year. Before we move to the presentations itself, just a little bit of housekeeping. And Paddy, if I could have in the next slide, please. So the seminar itself will run through for 16 minutes. After the 2 main presentations, a 5-minute Q&A, a question and answer session will follow after each of the 2 presentations. Please submit your questions through the Q&A function, not the chat function, but the Q&A function. We may need to group the questions into topics for answer, and any questions which aren't responded in the time available will be responded to by email. In terms of the mechanics just of the Q&A, to ask a question from the panelists, click on the graphic with 3 horizontal dots just at the top of your screen. After clicking on the 3 dots, click on the Q&A option, which will come up in the drop-down menu, and enter your question in the box provided. Paddy Savage. Paddy is Head of Ammonia Policy Branch. You'll see Paddy at the top of the screen. Will collate and relay the questions to the panel. Recordings of each of the webinars will be made and will be available online. If we could move to the presentations itself on the next slide, please. On today's seminar, we have an introductory presentation which is going to be given shortly, and 2 main presentations. Sarah McCookin Naya will give an introduction to our ammonia science workstream. Elizabeth McGowan-Affey will then focus on the research programme, which DARA commissioned following the expert working group's report, Making Ammonia Visible. And finally, Keith Finnegan, NIEA, will present on the ecological impact of ammonia emissions on habitats. So turning to the introduction itself to our ammonia science work programme, I would like now to pass over to Sarah McCookin. Sarah is Head of Natural Science within NIEA. Thanks, Sarah.
Thanks, Alistair. Good afternoon, everyone. I'm delighted you could join us all for our week of webinars around the ammonia science workstream. What we thought we would do was really just set the context and introduce this particularly pressing issue, a significant issue for both agriculture and the environment, and explain the basis of the ammonia challenge that we're dealing with. So starting back to basics, ammonia, as many will know, is a form of nitrogen, and in Northern Ireland is largely associated with slurry management and to a much more limited degree fertiliser spreading. It's well recognised to be a powerful air pollutant, which does have significant implications for biodiversity, both within our designated sites and the wider countryside, and also in terms of human health and its role in the formation of fine particulate matter. In Northern Ireland, the bulk of our ammonia emissions do come from agriculture, and while we did have a peak back in '96, emissions had dropped off, but we have been steadily rising since 2010, and we're back up and beyond the 1996 levels. And so we do need to work on how we reverse that trend. What we also need to set out here is the importance of the sector, the agricultural sector, that I suppose is involved in the ammonia emissions and helping us find the solutions through this. is we need to set out the important role that it plays to the Northern Ireland economy and to our rural community, and has a significant value of £5.1 billion to Northern Ireland every year. It is a particular issue, or ammonia emissions are a particular issue in Northern Ireland because of the nature of our agricultural production and the predominance of livestock production, which is associated with ammonia emissions and associated nitrogen deposition, which impacts our biodiversity. So it's very clear that we do need to work together, because the current level of ammonia emissions is posing a barrier to achieving truly sustainable agriculture and needs to be addressed to ensure that we can meet today's climate and biodiversity challenges. Turning to the next slide, Patty. I think it's well recognised now the role that nature and a fully functioning ecosystem plays in supporting society. I think through the lockdown, there has been continued coverage through the mainstream media around the role and comfort that people have been able to secure from spending some time in nature, and it has made it clear that we have to work harder to address deterioration in our ecosystems. It does play and will continue to play a key role in contributing to climate change mitigation and adaptation. And 2021 will be an important year for nature. It will be the start of the UN Decade for Ecosystem Restoration. We will have the two COPs, or Conference of the Parties, both for the Convention on Biological Diversity and also for the UN Framework for Climate Change. For both of those COPs in May and November, the key role and links between nature and climate will be particularly focused on, and we will want to make use of that opportunity to really set the tone and direction for agricultural and environmental development moving forward. I think you'll have seen, even in recent press, the issue that we have in terms of the significant and continued biodiversity loss in Northern Ireland and globally, particularly in the last 20 years. Most of our priority habitats and species, upon which we will rely on to help us address climate change, are in unfavourable condition, and they also are, many of them, particularly sensitive to nitrogen deposition and local ammonia emissions. 282 of our ASSIs, our areas of special scientific interest, are sensitive to nitrogen deposition. Turning over to the next slide. So I think it's clear that we have a lot to do. There are a number of commitments that we have already to reduce pollution and to restore the natural environment, both within the Gothenburg Protocol and the National Emission Ceilings Directive to reduce our ammonia emissions, with ammonia being one of 6 key air pollutants that need to be addressed. Our clean air strategy will be driving improvements in air quality and ensuring that we're addressing ammonia emissions, which do lead to the formation of fine particulate matter. We have a range of obligations, both in terms of biodiversity, ecosystem services, and now increasingly climate change, to restore our priority habitats and species, and to ensure that we have the adequate protection and conservation measures in place to allow that to happen, and to happen quickly. And this will be particularly important for our areas for nature conservation, both in terms of designated sites and those areas of the wider countryside that are important for nature recovery. So we do need to reduce our emissions and direct our conservation actions appropriately to help nature recover. Next slide. There's a lot going on in the background in terms of how we are drawing together the necessary conservation measures to restore our habitats. And some of this work here complements the wider research programme across the rest of the department in this arena. We're trying to identify conservation measures, both in terms of protection and on-site restoration, that will deliver for our special areas of conservation and other key sites through the development of management plans. making sure that we better understand the specific ecological impacts and responses to various types of emissions, whether it's local or wider, and also to ensure that we are accurately detecting nutrient enrichment even at the early stages, so that our on-site management and habitat restoration programs are designed with that in mind to be able to build habitat resilience. We are looking very specifically at profiling of each of our sites. All of our designated sites are very different and have a range of features that need to be protected. They're all at various stages of conservation status that needs to be targeted. And we also need to have a better handle on the types of sources from both wider and local in terms of ammonia emissions, to ensure that we are effectively targeting emission reduction strategies and have better informed habitat restoration programs moving forward. Ultimately, to ensure that we can move towards favourable conservation status and be able to support agricultural development and green growth. So we will be setting out in more detail some of those work areas, but I'll hand over to Alistair, who will introduce the research programme, and Elizabeth, who will be moving on to detail that.
Thanks, Sarah. So this slide outlines, to complement the work that Sarah detailed, DARA is funding a major research programme on ammonia to build on our evidence behind ammonia science. The research programme has been commissioned and is led by the Agri-Food and Biosciences Institute, AFBI, in partnership with the UK Centre of Ecology and Hydrology in Edinburgh and Rothamsted Research based in Devon. The research programme includes addressing recommendations which were made in the Making Ammonia Visible report from the expert working group, with key aspects including emission reduction modelling, economic analysis, and a greater measurement of ammonia emissions at Northern Ireland farm and habitat level. The series of 3 seminars that we're holding provide an opportunity to hear from the leading scientists on the important new information this research programme has produced over a series of 3 seminars, which are just outlined in the next slide. Brief overview of the 3 seminars is given here, highlighting today's focus is on the research programme and the ecological impacts of ammonia. And so now let's turn to Elizabeth McGowan, Director of Sustainable Agri-Food Sciences Division within AFBI. Elizabeth's presentation is entitled Ammonia Emissions for Northern Ireland, the Research. Within her role, Elizabeth oversees a wide-ranging portfolio of research and science, which aims to lead to improvements in the agri-food sector, in tandem with enhancing Northern Ireland's natural and marine environments. Through this role, Elizabeth oversees the ammonia research programme in AFBI. Thank you, Elizabeth. We're looking forward to your presentation.
Thank you very much, Alistair, and thank you for the opportunity today to overview this quite substantial research programme which DARA has funded and commissioned recently. So, Paddy, just to move on to the first slide, please. So before we start actually explaining the research programme itself, it's important to understand where it came from and what its basis was. So the first piece is really understanding the key gaps in knowledge, or where the knowledge base really needed to be increased. So this very much came out of the expert working group's recommendations, and over the next 2 slides, I have really tried to sum those up into the 2 main areas. So the first area was around data and modelling. And with regards to data and modelling, there was a recognition that the amount of measuring and monitoring of ammonia needed to be enhanced. And that included the expansion of the monitoring network for atmospheric ammonia and nitrogen deposition. It was also deemed really, really important to cost out what the impact of the mitigations that the expert working group suggested would be, and then using that cost effectiveness to try and prioritise which mitigations would be taken forward in any future ammonia strategy. The third area under this data and modelling section was then really to improve and communicate the scientific evidence base, and especially to make better and robust assessments at both the farm and Northern Ireland level with regards to the impact that the ammonia mitigation suggested by the EWG could have. Okay, Paddy, thank you. The second big area then where there was a real need to increase the knowledge base was around livestock and farms. So this in particular was around the need for an emission factor for slatted floor systems. I'll describe in a little minute the model chain that is involved in the ammonia decision-making process. But at the very start of that is the Narcissus model, and within the Narcissus model there is an emission factor for solid floor systems. There isn't an emission factor for slatted floors. Now, whilst research and experiments out there would suggest that there's not that much difference in ammonia emissions from slatted and solid flooring, it is of course prudent to have an emission factor for slatted floor being used in the inventory calculations. The second main area then under livestock and farms was really about quantifying and adopting the impact of lower crude protein. Of course, we know that our poultry housing has modernised over the past few years, with dry heating now predominant, and that needed to be recognised within the inventory. And any updates to nitrogen excretion due to this improved efficiency from cattle, pigs and poultry also needed to be fed in. The third big area then was really looking at an independent evaluation, if you like, around the costs and benefits of a range of slurry additives that are on the market. And then finally it was also about trying to see how low could we really push crude protein intake in livestock. And very importantly, to doing this while maintaining or indeed enhancing livestock performance. If we didn't do it in tandem with maintaining that performance, we would lose the benefits of reducing it. So what we designed then alongside DERA and our colleagues in the UK Centre for Ecology and Hydrology and Rothamsted Research was an ammonia research programme, and we've tried to brigade it under these four main areas. So the first area is around sharpening the inventory, in particular focusing on the activity data and emission factors, and I'll tell you in a little minute why that was important. The second big area was that modelling and data piece, to understand the flows of ammonia, to understand what the contributors were, ground truth models, to scenario plan for farms in the Northern Ireland scale, and of course the cost through those scenarios. The third area then was about really taking things forward, testing new mitigations, especially in the area of dietary manipulation. And then the fourth area, which the EWG was very passionate about, was about making ammonia visible. Thank you, Paddy. So before I get into what the actual research programme is covering, it's in a very high level, but a little bit more detail, because my colleagues during the week will present on the main findings to date. I think it's prudent to help you understand just what the key aspects are of the ammonia decision-making process within the UK. And there's a very sophisticated model chain involved. Now, at the very start of that model chain is the Narcissus model. And this whole business of reporting and having an inventory for ammonia emissions is critically important. As Sarah said earlier, we have legal obligations to meet into international committees. So it's fundamentally important we have a robust inventory to report to those legal obligations and international committees. So as I say, the very first model that's used in this model chain is that was called the Narcissus model. Now this model is Tier 3 accredited, and that basically in its very simplistic terms means that the equations and the interrelationships of those equations within the model are accredited to the highest possible standard, and that's really led by Rothamsted Research. The Narcissus model will adapt and adopt information on an annual basis and therefore update itself on an annual basis with any new evidence that we provide to it. It'll also then report on the emissions of ammonia from UK agriculture, again on an annual basis, usually about spring or early summer of the year, just depending on other maybe political pressures. But basically that is always reported on an annual basis and then compared right back to a base point of 1990. It is what's called a nitrogen flow model. So again, to simplify this and hopefully not oversimplify it, basically if I take an example of a dairy cow, it'll consider the amount of nitrogen in the diet, it'll consider how much other dietary characteristics are, how well that dairy cow utilises the nitrogen, as a result how much nitrogen is in the resultant slurry. It'll consider the fact if that slurry is in a tank which is covered or an open. It'll consider how much Nitrogen is then available to be emitted as ammonia or taken forward in the slurry and applied to land. It'll consider how much of that nitrogen is applied due to it being a splash plate or a trailing shoe, etc. And as a result, how much ammonia emissions could then be produced. So at each chain of the biological process, it'll consider how much nitrogen is utilised at that stage and therefore how much nitrogen is left to potentially be volatilised as ammonia. So there's two key inputs to the NARCIS model. The first one of those being the activity data, such as the number of dairy cows out there, the number of pigs, the number of sheep, etc. The fertiliser use, farm practices, and that, again, very simplistically, is effectively multiplied by the emission factor of those farm practices. Okay, Patty, move on, please. So, as I said earlier, the NARCIS model is the first model in the model chain, and the NARCIS model produces those UK ammonia emissions. So we know how much ammonia emissions are on the UK as a whole, as well as for Northern Ireland, Scotland, England, Wales, or for the dairy sector or the beef sector, and for different farm practices. However, that's a lot of data. What happens then is that information is fed into what's called the ENID model. And again, very simplistically, that ENID model basically knows where the livestock and where the farm practices are across the UK. And it will then map for us how much emissions are being emitted up into the air, into the atmosphere from the farm practices. So it effectively spatially disaggregates the emissions at a 1 kilometre grid level. So that's the emissions that's going up into the air, if you like. That information is then fed into the frame model, and the frame model, again, in its very simplistic terms, maps where those ammonia and nitrogen depositions are coming back down again onto the landscape. So the frame model will give us a UK ammonia concentration and nitrogen deposition maps, as well as in the critical level exceedance at various locations across the UK. This information, in combination with other data with regards to nitrogen-containing gases, is fed into what's called the seabed model, and that seabed model then informs us about the critical loads exceedances at various locations across the UK. So this whole chain is really ran between Rothamsted Research having a key role in the NARCIS model, and then the UK Centre for Ecology picking up from the ENID through to the seabed model. Thank you, Patty. So with that in mind, that activity data that's fed into the NARCIS model is critically important. And that was one of the very first pieces of work that we started within the programme. And we were able to identify quickly some of the low-hanging fruit that we could change. So for example, we were able to change the percentage of pigs that were on straw and outdoor back onto flats. We looked and increased the days housed for cattle. We also made changes to reflect the modern poultry systems that we now have. And those changes will be reported through in the 2019 reporting, which is due out next year. However, there's more granular work to be done, and there's ongoing work in this space where DAERA is taking through some exercises to try and collate some more detail around some key farm practices. And then ourselves in AFBI, we are leading on trying to refine the dietary inputs to the NARCIS model, and that's very much being done in collaboration with NICTA as well as DAERA. Thank you, Patty. So what I described earlier was the activity data, and then that was effectively multiplied by the emission factors of farm practices. So as I said earlier, the EWG very much recognised that there was a need for an emission factor for slatted flooring systems, for cattle and pigs, and that work's being taken forward at the minute. It is very challenging to establish an emission factor for cattle, so I don't want to overpromise just at this moment in time, but we are certainly trying our best to establish that. But as we reviewed the inventory, we recognised that there was a need to refine some of the other emission factors, for example, grazing for cattle and sheep, to refine the emission factor being used for our modern poultry housing, and indeed for some of the low emission spreading techniques, for example, the trailing shoe and the dribble bar. And the emission factors for the grazing cattle and poultry are currently underway, and the emission factor refinement for the less technologies will start now in the new year coming. We have a programme of work that's continuously revising the nitrogen excretion from cattle, pigs and poultry, and where new evidence becomes available on that, it is of course being fed into the NARCIS model. Thank you, Patty. So that being the first main area, we're now moving into the second key area of the research programme, which is modelling and data gathering. And this was a lot of the body of the work here will actually be reported on throughout Wednesday and Friday, and indeed has very much informed that forthcoming draft ammonia strategy, which the intention is hopefully to consult on into the future. So you can rest assured that the information from this programme of work has absolutely been used, hopefully effectively, confidence effectively, into the draft ammonia strategy. So what that looks like is, first big area was about ground truthing the data. So I described earlier on the frame model. And that was the model that calculated and mapped out where the ammonia concentrations and nitrogen deposition came back down onto the landscape. So we had 3 sites across Northern Ireland which collected data for that frame model. We expanded that to 28 monitoring sites, and at this stage we have 1 year's worth of data against those 20 monitoring sites. And it's very pleasing to be able to report today that we're finding good agreement between the actual levels of ammonia being monitored at those sites and the ammonia concentrations being predicted by the frame model. But Yuli will expand on that further on Friday. Second big area there was to try and model the impact of the ammonia mitigations that the EWG group suggested, and what their impact would be on Northern Ireland from how much ammonia can we actually reduce at a Northern Ireland level based on acceptable adoption rates, and what kind of effect will that have on our sensitive habitats as modelled through the frame model. So again, John and Yuli will present the findings from that piece of work on Friday. So that was at a Northern Ireland-wide level, but we also wanted to look at that at a farm level. So how much, if a farmer took up a number of these mitigations, how much ammonia could he reduce being emitted from his farm? So we looked at typical scenarios for dairy, beef, pig and poultry farms, and looked at different scenarios of mitigations there to really demonstrate how much at a very local farm level we could reduce ammonia. And John McElroy will present on those findings on Wednesday. Also on Wednesday then, Erin Sherry will present on what we've modelled through as the economic impact at a Northern Ireland level if these ammonia mitigations were adopted. So as I said earlier, all of this detail will be presented later in the week, but it's also fed into the draft ammonia strategy. Thank you, Patty. So the third area then is a bit more forward-looking, and that's around designing and testing new mitigations. So as I said earlier, a big focus of that is dietary manipulation. And what we're looking at the minute in collaboration with a number of industry partners is how low can we push crude protein in pig diets? Can we push to 12% in the finisher diet? In dairy diets, can we move from the current 17, 17.5 down to 16 and maybe even lower? For poultry, can we reduce 2% in the starter, grower and finisher diet? So these are all things that we're trying to work through and work with the industry partners to really see how low we can push crude protein in the diet whilst not having that detrimental impact on performance. From a slurry additives perspective and a slurry management perspective, we plan to investigate the impact of aeration, separate and separation. And aeration is especially interesting because we know it can decrease the amount of hydrogen sulfide in the gas, but there's contradictory evidence with regards to its effect on ammonia emissions. So our work will help us to understand why that contradictory evidence is coming through, and indeed try and develop up, can aeration actually reduce both gaseous emissions, which should be very beneficial. We'll also be looking and taking an independent evaluation of a number of chemical and biological additives. But all of these additives are all about adjusting the pH in the slurry because that changes the equilibrium of actually emitting ammonia emissions or not. So we'll also, in the concept of a biocircular economy, be looking at waste streams potentially as additives to the slurry to adjust its pH. We're also working with Moore Concrete up in Ballymena, looking at novel flat designs and some floor management strategies, again, trying to reduce ammonia emissions. Okay, Paddy? So the last slide here is around that piece on making ammonia visible. And again, John McElroy will present on this piece on Friday, but just briefly to highlight that Aspie Hillsborough is a very concentrated base for livestock, as well as having an anaerobic digestion plant. So what we've done there is we have a continuous monitoring site for ammonia about 200 metres upwind of that farm. We're constantly monitoring the activity of the farm, animals in, slurry movements, etc. So we have a daily spreadsheet of key activities across the farm. We're constantly measuring the weather. We're taking ammonia emissions every minute, as I say, upwind from the farm. And this is really feeding into a unique resource for us to be able to model farm activity with atmospheric ammonia and the weather impacts around that. And as well as being a unique research resource, we're also working on our website at the minute to be able to demonstrate to stakeholders those main causes and effects and help that understanding of making ammonia visible and what the key contributors are. Thank you. And I'm happy to take questions now.
Thanks, Elizabeth, and welcome also to John McElroy, who's actually on the panel. Elizabeth referred to his work in the presentation. John's a senior scientist at Aspie, and Tom Misselbrook's also on our panel this morning from Rothamsted Research, joining Elizabeth, Sarah, Paddy, and myself on the panel. Paddy Savage heads up ammonia policy branch within the department, and Paddy's going to be collating the questions. And Paddy, could I pass over to you to relay the first question?
Yeah, thanks very much, Alistair. And then, just to remind folks that if you use the Q&A function, we can pick up your questions from there. And thanks to those who are already using it, and some really, really good questions, really interesting topics being raised. The first question, I think, is perhaps Alistair and Sarah. It relates to your background presentation, and it's around has the environmental farming scheme, which started in 2018, perhaps that had been a particular tranche of it, but has it made any difference to designated sites, biodiversity, and our air quality so far? I don't know if Sarah, if you maybe want to pick up on that one initially.
Yes, happy to, Paddy. The environmental farming scheme and the range of measures within it were specifically designed to address, I suppose, those pressures and threats within designated sites, and also to help with habitat creation and some of the other environmental quality issues outside designated sites. So it's still too early to say at this stage, but we have developed a detailed monitoring and evaluation framework, which is specifically designed to detect any changes in the environmental metrics and to help us to examine the effectiveness and suitability of EFS to deliver those policy outcomes. But we are confident that where, for example, with designated sites, the site-specific remedial management plans have been put in place. They have been designed on the basis of detailed assessments of the condition and potentially the reasons where a site is possibly on unfavourable condition. So even the removal of those pressures will mean that the site will start to move in the direction of favourable conservation status, notwithstanding that ecological responses take some time. But we have probably going to spend the next 6 to 8 years monitoring various aspects to ensure that we are able to detect and be able to attribute any environmental improvement to the measures that were put in place under EFS.
Thanks, Sarah. And then just moving on, Elizabeth, in relation to your presentation, there's a question in here just about the relationship between increasing the time spent in animal housing and just really the relationship between time spent in animal housing and ammonia emissions. And if you could just maybe comment on that, Elizabeth.
Sure. So, and Tom can back me up here, the biology behind the creation of ammonia is such that ammonia is created when urine and faeces mix. So in a house, there's a much higher probability of ammonia and faeces mixing than in the field. And that's quite a simple theory behind it all. So yes, housing does increase the amount of ammonia emissions, and John will demonstrate that very clearly, I think, on Wednesday through some of the scenarios that have been modelled through with regards to indoor housing and more extended grazing from the dairy cow system. But it's back to the simple biology, and that's why it's important that we're looking at novel slat designs and floor structures and slurry additives as well to try and mitigate the feces and the urine mixing as much as possible at those early stages of the cycle.
Okay, thank you, Elizabeth. Just another question on, do we know how much ammonia is generated from imported soya? And, is this sustainable on a global level, and reference the links to deforestation?
So I think maybe that individual's getting more a carbon footprint. So the deforestation of soya would link more to the feed ingredients carbon footprint. Ammonia is an indirect greenhouse gas, but ammonia is mainly generated from, as I say, the nitrogen intake of the animal and the feces and urine mixing and how you manage the slurry at a later stage. So ammonia is a localized gas, whereas methane in the carbon footprint story is a more global gas. So ammonia is a localized issue more so that the soya deforestation doesn't really come into it. But from a soya perspective, it's all about reducing the crude protein. If we can drive down the crude protein in the diet and drive down the content of soya, that will help reduce ammonia emissions. But as I say, we've got to be really, really careful we don't do that and to the detriment of animal performance. And of course, soya is a very good protein source for the pig and poultry diets in particular.
Okay, thank you. And then just one final, very quick question about the models and how do they link to trying to work out if there's more capacity for animal production in advance of additional mitigations? And any comment on how the models link to that? I suspect not to put words in your mouth, Elizabeth, but from the models really tell us what the position is at the minute, and then I suppose it's maybe a policy question then about what the implications of that are.
Yeah.
Do you have any particular comment additional on that?
So I suppose, again, being very academic about it, yes, the models can help us model through the number of livestock and their impact on ammonia emissions. Within this research programme, we are very much focused on, we have X number of livestock in Northern Ireland. If we applied these mitigations to that, what would the impact be? So we haven't touched on the question of looking at animal numbers and modelling that through. We have used what is the current status quo in Northern Ireland and how can we reduce the ammonia emissions from that current status quo.
Okay, thank you, Elizabeth. Look, there's lots of other questions. We'll also respond to those after the session, but we're a minute or two behind time now, so I'll just pass back to Alistair.
Thanks, Paddy. And we're going to move on swiftly now to Keith Finnegan. Keith's a principal scientist within the Northern Ireland Environment Agency, and Keith's going to present on the ecological impact of ammonia emissions on habitats. And we're going to get a good overview of the impact of ammonia emissions on habitats from Keith. So thanks, Keith.
Afternoon all. Yes, my name is Keith Finnegan and I head up a small team in Natural Environment Division that gives advice on air quality and biodiversity. Move on there, Paddy. Thanks. So if we're going to talk about the ecological impacts of ammonia and nitrogen, then we need to know how the nitrogen gets from the source to those habitats. Now, I expect you're going to see this slide quite a bit over the next couple of days, and it's going to be explained in more detail, but just a very brief overview. When we're talking about atmospheric nitrogen, two main types: oxidized nitrogen, which is produced primarily by combustion processes, so traffic, industrial processes, heat generation, energy generation, etc., and reduced nitrogen, which is ammonia and ammonium, and it's primarily agricultural. So 97% of our ammonia in Northern Ireland comes from agriculture. Then when we're talking about how that nitrogen gets from the source to the receptor, we're talking about dry deposition, which tends to be close to source. And in those cases, if you're trying to build a livestock shed, for example, then how close you are to the protected habitat is going to be very important, and wet deposition, which tends to be more long range. And I suppose what we're going to see over the next couple of seminars is how we measure, model the emissions from the source, and how we may stop or break that pathway to the protected habitats and other receptors. Thanks, Paddy. Next slide. So when we look at Northern Ireland and compare it to England, Scotland, Wales, you can see that we have a significantly more reduced nitrogen than either of the other countries in the UK. That goes back to our agricultural systems and the fact that we're primarily livestock based. Next slide, Paddy. Okay, and before we go into a bit more detail, I'm going to explain a couple of terms just to make sure we're all singing from the same page. The critical loads relates to the quantity of a pollutant deposited from the air to the ground, below which harmful effects are unlikely to occur. They're set under the Convention of Long-Range Transboundary Air Pollution, which was last updated in June 2010, and they're importantly habitat-specific. So in this example on the screen, you see raised and blanket bogs, and the critical load is 5 to 10 kilograms of nitrogen per hectare per year. There is a book, picture of it on the side there, which details all the evidence that was used to determine those critical loads per habitat. Next slide, Paddy. Thanks. Critical levels, on the other hand, relate to the concentration of a pollutant in the atmosphere above which direct adverse impacts may occur. They are not habitat specific, but have been set to cover broad vegetation types. And for ammonia, there's two. There's 1 micrograms per meter cube, which is our most sensitive bryophytes and lichens, and 3 micrograms per meter cube, which is for all other plants. Next slide, Paddy. Okay, so if we look at nitrogen deposition on the European scale, and the graph you're seeing is for the Atlantic Biographic region of the EU, this study looked at grasslands throughout all regions there, and you can see Ireland, Northern Ireland are the light pink dots. Now, just when you're looking at this graph and the following graph, bear in mind that for the majority of our designated sites, protected habitats in Northern Ireland, we're talking about in and around 20 kilograms of nitrogen per hectare per year. On the y-axis here, we have species richness of those grasslands, and you can see at that 20 kilograms of nitrogen per hectare per year, you would expect to see a significant loss in species richness. Next slide, Paddy. Then this is an English study that went a bit further. It looked at 5 different habitats in England, and again, similar outcome: nitrogen deposition along the x-axis, percentage of expected species along the y, and again, you can see that with increasing nitrogen deposition, you get decreasing species richness. And again, at the 20 kilogram of nitrogen per hectare, there you can see that you are about 40 to 50% of the species that you might expect on that habitat. Next slide, Paddy. Okay, so what does that mean in Northern Ireland? Well, the picture's not great. 98% of our nitrogen sensitive special areas of conservation are exceeding critical loads. 88.3% of our nitrogen sensitive ASSIs are exceeding critical loads. And of all our habitats across Northern Ireland, 81.2% are experiencing deposition of nitrogen above the critical loads. Next page. For critical levels, similar situation. 91% of SACs above the 1 microgram, 89% of ASSIs above that 1 microgram where damage occurs to most sensitive habitats. And across Northern Ireland as a whole, 91% of our land area is exceeding that critical level. And this is a higher proportion than found in England, Scotland, and Wales. Next slide, Paddy. So what we're going to do now is look at a number of Northern Ireland sites. Ballinahone Bog, which has extensive damage as a result of nitrogen and ammonia, and it's probably our most investigated site. Gary Bog, which is intermediate damage that can be related to nitrogen and ammonia. Loch Navarre Scarps and Lakes, which is our clean air site. It's the cleanest air in Northern Ireland, and the critical levels aren't exceeded. And if we have time, which I doubt we have, we look at Munanea Bog, which is an example of how a site can recover. We should point out the reason I'm talking about bogs here is because it goes back to that make ammonia visible, and it's on bog habitats that these impacts are really the most visible because of the nature of the damage. Next slide, Patty. Okay, before we go further, if you want to know about a site beside you, near you, a protected habitat, or what the critical loads and levels are for a particular habitat, check out the Air Pollution Information System. You'll also have, for example, in there a plant effects gallery, which details what the impacts of a particular pollutant looks like, and you can check the critical loads and levels or what sensitive features are on a particular site. Next slide, Patty, thanks. Okay, so our first site, Ballinahone Bog. As I say, this has been extensively surveyed and studied with regards to nitrogen over the last couple of years. It's a lowland raised bog. The critical level and critical loads for all these sites we're looking at are going to be the same. The critical level is 1 microgram per meter cubed, and the critical load is 5 kilograms of nitrogen per hectare. Now you can see at the bottom of that slide, the average nitrogen deposition currently is 20.6 kilograms of nitrogen per hectare. That's a lot of nitrogen coming from the air onto a hectare. And the maximum annual concentration is 2.6 micrograms. Okay, next slide, Patty. So working with the partners in Ulster Wildlife and UK Centre for Ecology and Hydrology, ammonia levels at this site has been monitored since 2014. And you can see there in the graph, obviously the month 1 is January, month 12 is December, and you can see there's a general seasonal aspect to ammonia concentrations. You get a peak coming in February and March when the close season finishes and slurry spreading starts, and that's a level maintained throughout the summer. And then when the close season, slurry spread and close season starts again, you get a decrease in emissions. Now, obviously, there's some anomalies in there, a significantly high peak in the spring of 2019, and a sustained high peak in the winter of 2018, which we're not 100% certain about, but may be due to climatic factors. Next slide, Patty. We're also looking at the emission density across this site, and the reason I've got this up is because there is still the perception among some people that this is a particular issue for example, the pig industry or the poultry industry or the regulated industry. And really what I want to demonstrate with this slide is that actually it's all livestock sectors that have a role to play in reducing these emissions. So this slide shows buffer zones in increasing increments of 1 kilometre along the x-axis, and the emission density in kilograms of nitrogen per livestock sector. And this is all agricultural sectors, where the light blue is our other sources. It simply means there's less than 5 developments of that particular livestock sector in that area. So you can see that, for example, if you look at dairy there's a significant proportion of emissions from dairy across all sectors, all buffer zones. Next slide, Patty. Okay, so what are we seeing on this site? Well, one of the main indicators we use is cladonia. And what you see here, cladonia should be that silvery green color. And what you can see here is a distinctive pinking. That's the algal part of the lichen breaking down and dying. You get a loss of structure, and you get complete breakdown of the exposed lobes, and the cladonia, the lichen becomes slimy. Next slide. You get, on the heather, you get bleached, loss of green photosynthetic material, and the burr stems become covered in algae. Now, that algae is receiving all its nutrients from the air, so there has to be a significant amount of nitrogen in the air for the algae to grow. Next slide, Barry. You also get some positive indicators of nitrogen. This is Xanthoria. This is a lichen that likes high nitrogen levels. You'll typically find it along roads, on the walls or railings along roads, or even on livestock housing. You should not be seeing this in the center of a raised bog. Next slide, Patty. And then most importantly, damage to the sphagnum itself. This is the peat forming species that bogs need most of all. On the left-hand side, you see healthy sphagnum, and on the right-hand side, taken in close proximity on Ballinahone, dead sphagnum. You can't really even tell it was one sphagnum. And what you get is a gradient of damage, sometimes in the same hummock, of healthy sphagnum, then you get sphagnum covered in increased agricultural growth. The sphagnum begins to break down, and then you get finally death. Next slide, Patty. Okay, Gary Bog. This is slightly further north in Ballinahone. Same critical level, same critical load. Noticeably, almost the same deposition, 20.2 kilograms of nitrogen per hectare, but lower ammonia concentrations, 1.9 microgram per meter. Okay, next slide, Patty. Oh, sorry, next slide, Patty. Not sure what's happening there. Oh, back one. Maybe the photographs just took a while coming up, did they? Yes, there you go. So on this slide, these photographs all taken in Gary Bog, you see the same damage as we've seen in Ballinahone. You see the pinking of the cladonia on the left-hand side and the breakdown of that cladonia lichen, and you see the algal growth on the bare stems of the heather. Next slide, Patty. I'm not sure this might. Okay. Also in Gary Bog, you see an increased dominance of the grasses and sedges taking the place of more traditional bog species, if you like. And on the right-hand side here, you see relatively heather sphagnum towards the bottom of the photograph, then increase in slime and breakdown of the structure of the sphagnum until you get almost dead sphagnum at the top. In fact, you can't really tell it is sphagnum at the top of the picture. Now, interestingly, on this site, the damage, the indicators of the damage are the same, but it's not as widespread as Ballinahone bog. Next slide, Patty. Okay, just before we go on, it's worth saying that both Gary Bog and Ballinahone bog, which we have just looked at, are both exceeding their critical levels. We're putting management plans in place with as part of the CAN project for them, and they've both been surveyed recently by Ulster Wildlife and AFBI. And the conclusions of those surveys have been relatively similar to our own in the outcomes, in that they're both unfavourable. Okay, Loch Navar is a good news story, relatively good news story in terms of Northern Ireland. It's a clean air site. It is a mixed upland mosaic, but we're looking at the bog aspect of that mosaic here, which has the same critical levels and critical loads at the other two sites we have looked at. Notably here, the ammonia concentration is below 1 micrograms per meter cubed, but the deposition is 7.5 kilograms of nitrogen per hectare, and that is slightly it's in the middle of that critical load range for bogs 5 to 10. It should really be below 5. Next slide, Patty. And in this site, what we see we clumps of cladonia. There's no pinking. They're big and they're widespread throughout the bog. On the right-hand side, we see healthy sphagnum. It's not slimy to touch. There's no algal growth growing over it, and it's extensive, so it covers almost the entirety of the grid square. Next slide, Patty. Okay, so and in this picture, the last for this site, instead of the xanthorial lichens we see, we have osmia growing on this, which is really doesn't like nitrogen and is an indicator of low nitrogen in the air. Now, as I said at the start, when we were looking at Loch Navar, the critical load is exceeded here, and on the right there you do see examples of algae-covered sphagnum, as we can see here, but they are few and far between and far less predominant than in the other sites. Next slide, Patty. Okay, we're also looking at some biomonitoring work, and we've looked at this across 3 sites, Ballinahone, again with CEH, Monaghan and Loch Navar. If we just start Loch Navar, 10 kilometres from the nearest big source, and as you would expect, the ammonium concentration in plant tissue is very low. Monaghan bog, the blue and the red dots, you can see a decrease in ammonium concentration in plant tissues from the source to moving away from the source, but Ballinahone bog is slightly different. You get significant ammonium concentrations in the leaf tissue no matter how far you are from a source on that site, and we think that has to do with saturation from those peaks that we've seen in the earlier graphs. the bog is effectively saturated, so the plants are fully taken up. Next slide, Patty. Okay, so I've stuck this next couple of photographs in to remind me of something. It's basically to remind us of our internal biases. And one of those biases that scientists and everyone else have is false baselines. This is a picture of a hawthorn tree taken at Loch Navar. And its absence of leaves shows that it was in midwinter. And you can see the biodiversity that this simple hawthorn tree can hold. There's a multitude of species of lichens, mosses, there's bryophytes growing on it. Next slide, Patty. I don't know what's happening here. Yeah, so there's even, this is oak lungwort, which is used, it's a lichen that's used to treat respiratory diseases. It does dirty air, but here we have it growing on a hawthorn tree. And we are now, while the whole of Northern Ireland is in the natural range of this lichen, we're now down to a handful of sites of where it occurs. Next slide, Patty. So I suppose what he wanted to use these photographs for is it's not about what habitats looked like 6 months ago or 6 years ago, it's what they should look like. And while I don't expect to see this range of biodiversity in hawthorns in farm fields or fences or along our roadways, we should be seeing this in our nature reserves, and at the minute we're not. Next slide, Patty. So in conclusion, environmental damage as a result of aerial emissions of nitrogen is happening, and we can evidence it. But it's important to remember that actions taken to reduce those emissions will prevent further biodiversity loss. It will enable sustainable development and allow us to produce or promote our agri-food as the best available, environmentally friendly. We get the knock-on benefit of protecting public health, and we deliver ecosystem services such as carbon capture and flood alleviation, etc., which saves public money. That's me, Patty. I don't think we have time for luck or money involved,
sure.
Unfortunately.
Thanks, Keith. Yeah, thanks, Keith, and thanks for presentation and going through your extensive range of examples there, Keith, and the time is available. So we are going to open it up now for discussion. Patty, and could I just pass over to you for to relay the first question?
Yeah, there's some thanks, folks. There's some really interesting questions that have come through. The first one, Keith, is a query about whether there's been any work on nitrogen deposition and invertebrates. And somebody who works on raised bogs that are particularly nitrogen sensitive and believes that they're seeing insect decline. So is that something that the scientific work you've outlined has touched upon?
We haven't done work on invertebrates ourselves, but I am aware of some studies that link impacts to invertebrate population, particularly butterflies, to nitrogen and ammonia levels, and there tends to be a decline there. So a lot of these species, and invertebrates in general, and all depend on those smaller lichens, mosses as a food source, and there will be knock-on effects to wider ecosystems.
Okay, and we have another question, Keith, in here about the difference in source between the N and the NH3 on Gary Bog.
Oh, well, to be honest, I don't know that offhand, but generally speaking, if you go to the Air Pollution Information System and click on the Source Attribution tab, you will be able to find that information. Now, that information will be from 2012, but it will be, as a rule of thumb, livestock tends to be our biggest source of nitrogen in deposition, but I can look that up and get back to the person who asked the question in specific.
Brilliant, thank you, Keith. And then there's also a query here about the fact that there are emission figures developed for agricultural ammonia. But then there's have emission figures been developed to account for peatland sites which are unfavourable condition as a result of excessive N deposition?
Yeah, so and I'm sure some of the modelers in the seminars to come will be able to answer this more fully, but basically when the National Emission Inventory is being collated, Northern Ireland supplies all the agricultural census data as you would expect, but also all the road traffic data and all the data from our energy generation, etc. So that's all fed into the models. And you can see when you look at the source attribution of our sites, the percentages that can be attributed to each source, so each source sector.
Okay, thanks, Keith. And then just one other, just a couple of final questions. One is, would controlled burning disperse the build-up of nitrogen on Meyer systems and clean or repair the system?
No, I would expect the burning would release nitrogen into the soil. So what you would really do if you wanted to reduce the nitrogen, you would cut the vegetation and take that off site potentially, but you certainly wouldn't want to be burning it.
Yeah. Okay. Thanks a million, Keith. Just in terms of the last couple of questions, I want here around reducing the link between reducing ammonia emissions and the green growth strategy. And I suppose that's from a policy perspective, certainly, the green growth strategy is something that's being developed by the department, but critical within that will be the need to reduce emissions. And I suppose
and maybe, Paddy, sorry, I'm just cutting across here because it's just struck 1 o'clock and I'm keeping tight to time here, but just maybe to finish on this, is something, Paddy, you want to immediately come in with just before I wrap up?
No, I'm happy for you to wrap up at this stage, Alistair, and we'll get back on those questions.
Okay.
To folks.
Okay, so this is the first of our series of 3 seminars, and just to reiterate the point that I made at the start, ammonia isn't a unique challenge to Northern Ireland. It's a particular challenge, but not unique. However, it's a lot we can do to reduce our emissions, while at the same time helping our agricultural sector to become more efficient and sustainable in the longer term. That's what we're going to address in the seminars coming up on Wednesday. I'm just looking down at the programme here, where we're going to cover farm case studies for reducing ammonia emissions and the economics of reducing ammonia emissions themselves. And then Friday, looking at the measurement of ammonia across Northern Ireland, which Elizabeth detailed, and the modelling of reduction scenarios themselves. So this reiterates really the challenge that we have in terms of ammonia, but that we are obtaining high quality science and increasing our evidence base, which will be the focus of Wednesday's and Friday's seminars to inform our proposals on a draft ammonia strategy as we move forward. I would like just to finish by thanking very much indeed our presenters, Sarah McGuckin from NEA, from Elizabeth McGowan from AFBI, Keith Finnegan, also from Northern Ireland Environment Agency, and also in the background, John McElroy and Tom Misselbrook were on the panel itself. And lastly, thank you very much indeed for joining us in today's webinar, and hopefully you'll be able to join us either directly at the times on Wednesday or Friday or at a later date on the recorded webinars themselves. Thank you very much, everyone.